Hello. So there's going to be what I call applications in capital budgeting. These are just special techniques that I want you to actually do. You're going to basically reproduce my table. Remember, you get out of this class what you put into it. So reproduce my table, and then we'll play around with a little bit, or you can play around with a little bit. First thing, pause it and retype everything up here on the top. None of this is equations except for the sum, well, not even the summation, but you can sum them up. This is the present value of each one of the projects. This is the expenditure per year. And this bottom one is the available sum of money that you have to spend. So if we take a look here and say it's equal to the sum and highlight this first column, apparently I hit a button incorrectly. Just group these guys. $615,000. We have a total to spend of $350,000. This is a capital budgeting constraint. The basic idea is that you're a CFO or a manager for the CFO. Somebody works for him. You have a bunch of plants or processes. They've all done capital budgets. They've sent them into you, and you're forming this to decide which ones we're actually going to do. So our present values, we're just going to type in, and our available funds, we're just going to type in. Down here, we want to create a column of ones and zeros. You can do them all ones. In fact, I'll just go through here. They're all actually going to be one, which means we're doing everything. Present value is just the 1 times the present value from above. The cash flow is just the 1 times the present value from above, and etc. As we go out here. We sum up the column, and the uncommitted funds is the difference between what we want to do, what we have to spend, and what we're actually spending. You can see here we're negative, which is absolutely not going to work. Also want to point out that some options are going to be things that are mutually exclusive. Like I have a choice of either to modernize a plant or build a new plant, but I'm not going to modernize and build. Alright, so we're going to control for this concept of mutual exclusivity too. What we're going to do is come over here and start up our data analysis. I'm sorry. We're going to start the solver. We're going to use the solver to do this. So what we want to do is for the total of present values, we want to maximize that. Right? We want to pick all the projects that maximize the net present value. And we're going to do that by changing this column of ones and zeros. Or they're all ones now, but of ones and zeros. So you're going to have to add a constraint. The first, you'll do that, like I'll just go ahead and delete this one. I'm going to add a constraint. The cell reference is this column. And the constraint, and the constraint that we're looking for is that it's binary. Binary means it's either 1 or 0. And then we're saying that B23, which is the build plant or modernize plant, has to be equal to 1. So we'll go ahead and delete that. We'll go ahead and add. We're going to say that this quantity has to equal 1. And that way we don't pick both of them. And our final constraint here says that E21 through G21. Okay, so that's E21 through G21 has to be less than or equal to E10 through G10. So for each individual year, we can't spend more than what we actually have available to us. Once you have those in, selecting the Simplex LP, you're going to go ahead and hit the solve button, and we'll go ahead and keep the solution. So here what we have is our choice variables, the projects that we're actually going to do. We're going to modernize the plants, we're going to redesign product B, and we're going to develop product A. or underneath each one of our values. And in fact, we have not committed 145,000. So that's using linear programming to go ahead and automatically select. Now, as an engineering manager for a large company with lots of plants and lots of capital projects, this particular spreadsheet had on a given year probably 100, 150 projects, well above what our total capital allowance was for any given year. Obviously, you also may have a requirement that if it's a safety object, right, an OSHA requirement or an EPA requirement, it's a 1, right? So you just include that right from the get-go. I could put a constraint in here that says that this one has to be a 1, for example. All right, there's a alternate functionality here from a solver standpoint. Again, we're going to try and maximize the present value. We're going to have binary, but we're going to say, and that B23 has to be 1, and that D21, so here's D21, has to equal a particular value, okay? So we want a particular amount of projects to be executed. And then we have our underlying constraints. We've increased our constraints here so that we can maximize our position. I'm just showing you that there's other ways that you can constrain this problem to answer individual specific questions of interest. So we have increases, decreases, etc. All right, again, your objective, reproduce this, run it through the solver. I want to see the same thing, and then we'll also talk about it in class. Thank you.